Everything you've ever known could be a lie. Your first kiss, the faces of your family, the feeling of reading these very words. What if it was all implanted in your mind a moment ago? What if you aren't the product of billions of years of evolution, but a single, lonely brain that just blinked into existence from nothing, complete with a lifetime of fake memories? Some cosmological models suggest this isn't just possible, but statistically, far more likely than the life you think you've lived. The terrifying question is, how could you ever know the difference? To get our heads around this, we have to start with one of the most basic rules of the universe, the Second Law of Thermodynamics. It says that things tend to get more disordered over time. Entropy always increases. You know this intuitively. An egg shatters into a mess, but you'll never see the mess spontaneously reassemble itself into an egg. Ink spreads out in water, but it never unmixes. Things fall apart. Order becomes chaos. That's the arrow of time. Now, if we assume the universe is a closed system, then its total entropy should always be going up. Over unimaginable stretches of time, it should eventually settle into a state of maximum entropy, a cold, featureless, uniform soup known as heat death, where nothing interesting can ever happen again. But just look around. That's not what we see. We see breathtaking order. We see spiral galaxies, burning stars, and complex planets. And on this planet, we see the impossibly intricate, low-entropy structures we call life. We see ourselves. The fact that we exist at all, that all this order is here, is a deep cosmic puzzle. Your own structured mind is a statistical miracle, a clash between the cold math of probability and the warm, breathing reality you experience. This is where 19th century physicist Ludwig Boltzmann comes in. He had an idea. Maybe the universe as a whole is a high-entropy wasteland, and our observable corner of it is just a rare, random fluctuation into a more orderly state. Think of it like a massive ocean, where for a split second, a tiny patch of waves just happens to form a perfect sandcastle before dissolving back into the water. A century later, physicists took that idea to its chilling conclusion. If random fluctuations can create order, what's the easiest kind of fluctuation that could produce a conscious mind? Is it a fluctuation big enough for a whole universe, with a 13.8 billion year history and a slow crawl of evolution? Or is it a fluctuation just big enough to pop the smallest possible conscious thing into existence, a single functioning brain? From a purely statistical point of view, the logic is brutal. The amount of order needed to assemble one brain out of chaos is astronomically smaller than what's needed for an entire universe. It's just so much easier to happen. This spontaneously formed mind, complete with memories of a life it never lived, is what we call a Boltzmann brain. And the math within certain models suggests that in a universe that lasts forever, these phantom observers would eventually outnumber normal, evolved observers like us by an incomprehensible amount. This leads to a dizzying thought. You are, statistically, more likely to be one of these hallucinating brains than a person with a real past. This is where it gets personal. How can you be sure your favorite childhood memory is real, and not just data loaded into a brain that sparked into being a second ago? You're experiencing a consistent reality right now, but a Boltzmann brain would be too. It would pop into existence thinking it had just eaten lunch, worried about a work deadline, feeling the whole weight of a past, only to dissolve back into nothing an instant later, never knowing it was all an illusion. This nightmarish idea can become a serious problem in certain models of the universe, especially those that go on forever. For example, cosmological models that describe an accelerating universe could potentially expand for eternity. And in an infinite amount of time, anything that can happen will happen, an infinite number of times. Over those timescales, quantum jitters in the vacuum would eventually spit out not just one Boltzmann brain, but an endless sea of them. They would become the typical observers. And from inside one of those fleeting minds, the world would feel just as solid and real as it does to you now. You might want to just shrug this off as a weird philosophical game, but cosmologists take the Boltzmann brain paradox very seriously. Why? Because it could break science itself. It's a key example of a huge puzzle in cosmology called the measure problem. How do you calculate probabilities in an infinite universe? If our best theories predict that most observers are Boltzmann brains, then we have to face the possibility that we are too. But if you're a Boltzmann brain, your memories are fake, and your senses are just random signals. You can't trust anything you observe. The experiments you run, the stars you map, the laws of physics you write down. It's all meaningless noise inside a momentary hallucination. As physicist Sean Carroll has pointed out, a theory that predicts its own observers can't be trusted is a theory that eats itself. It creates cognitive instability. This flies in the face of a core scientific idea, the Copernican principle, which says we're not special observers in a privileged position. We assume our view of the cosmos is typical. But if typical means being a disembodied, hallucinating brain, then our coherent, stable, non-hallucinatory experience suddenly looks incredibly special and rare, which creates a huge contradiction. This problem is so severe that physicists will actively try to find reasons to rule out cosmological models, just because they predict a universe full of these phantom brains. They are searching for a universe where you're allowed to be So how do we get out of this existential trap? How can we be sure we are who we think we are? One of the most significant lines of research suggests that the solution might be to challenge the idea of an eternal universe. Many cosmologists are now exploring models where our universe, or at least our patch of it, has a finite end. If the universe doesn't last forever, there simply might not be enough time for Boltzmann brains to form and overwhelm the population of evolved observers like us. A universe with a clear beginning, the Big Bang, and a definite end could put us back on solid statistical ground. But even with these potential escape routes, the paradox forces us to confront just how strange our existence is. The very fact that our laws of physics allow for this possibility shows how little we truly understand about consciousness, time, and reality itself. In the end, maybe the best argument against you being a Boltzmann brain is the fact that you're even thinking about it. You are following a complex, logical train of thought. You're feeling that pit in your stomach, weighing the evidence and looking for answers. Some argue that a true Boltzmann brain might just be a single, momentary snapshot of awareness. It wouldn't have the time or the stability to worry about being a Boltzmann brain in the first place. So this continuous, rational thread of your own mind, the one that's wrestling with this very idea right now, might be the best proof you have that you are not just a random fluctuation, but a real, thinking person in a truly astonishing universe. The cosmos is full of questions that stretch the limits of our minds. If you love exploring these deep mysteries, make sure you subscribe for more. And let us know in the comments, what mind-bending idea should we dive into next?